All right, so we are looking at new section, new chapter. This section is about quadratic functions. Got 4 things I want to cover in this section. 3 of them we ought to get to today. Thanks, Brenna, for bringing that up. All right, this thing right here, don't write it down. Let's just look at it. Came out of the book. You should be reading in the book. Let's see if it'll come back. Yeah, there it is. All right, let's look and see what this is really saying. I've got all these different terms. So here's a term, here's a term, da 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 da, here's a term, here's a term. And these n's are starting at some value n. This is what a polynomial function looks like. N's going to start at something, and then it goes down 1 each time. So if you're looking right here, it starts at n, and then it's n minus 1, and it goes all the way down to n equals 0 right here, and n equals 1 right there. That's a 0. So if x to the 0 power is just 1, then that's just a constant term out there. So all this is saying, you can have an unlimited number of terms starting at some value n and going down each time. So if n starts at 10, I could have n being 10, 9, 8, 7, 6, 5, 4, 3, all the way down to 0. Now remember, we're talking about where x is to the second power, right? Then it says these little a's out here, a sub n, a sub n minus 1. Those a's could be the same numbers. They could be different numbers. The only restriction, let's say, is that your first a, this one, can't be 0. So this is saying this example is of degree n. In other words, what's your biggest exponent? That's the degree. Okay, that's all that's saying. In the book, take a look at it, but we're just deciphering the math here. Here's an example. Look at it and say, do I need to write this down? Some of you are going to write down when you really don't need to, but that's okay. There's an example. Notice I'm starting at x to the 4th. So this is a 4th degree equation. Notice I'm leaving out some of the terms. It doesn't say all of them have to be in there, because a bunch of those other a's could be 0. It's just that first one can't be. Here's another one. Notice I'm leaving some terms out there. Then we get to here. Okay, if that went by too fast. Just some examples. Those are polynomial functions. Here's some common ones. Again, in the textbook. First one, this is saying f of x equals 2. Well, that just means y equals 2. Y equals 2 would be what if I graphed it? Just a horizontal line, flat line, and it would be 2 spaces above the x-axis. Notice that's just a constant function. Degree 0. Why? Because it's x to the 0 power. Next one. 5x minus 1. So y equals 5x minus 1. Linear, it's just a straight line. Slope is 5. Y-intercept is negative 1. Notice the degrees out here. What we're interested in this section are these quadratics. Notice it's degree 2. So that's going to, if I graph that, that's going to be a parabola of some sort, right? Then we get cubic and quartic. We're not going to worry about those. And it keeps on going up as the degree of the equation goes up. Which brings us to this. Since this is what we're concentrating on, here's quadratic functions. Notice, ax squared plus bx plus c. The only restrictions are a can't be 0. A, b, and c are just numbers. And look at what kind of numbers. Complex. Which means they could be imaginary. So we don't think of that very often because we don't see that pop up in most textbooks or problems, but they could be imaginary. A, B, and C could be imaginary numbers. The restriction is A can't be 0. Because if A were 0, what would happen? That'd be 0 times x squared. That term would go away. It wouldn't be quadratic anymore. It'd be linear, right? And if B were 0, then I'd just be down to that horizontal line thing. So here's the deal, though, this one. A couple of examples. Now look at my last example. That's one of our parent functions we talked about. All of those are going to be parabolas, but they're all of degree 2. Just a little bit of terminology here. These are parabolas, which means they're either going to open up or they're going to open down. That's our only two choices, isn't it? And you might go, well, wait. Couldn't I have one that opens this way? Is that a function? So no, I can't. These are all functions. It means it's either going to open up or open down. No sideways ones.
Good morning.
All right, notice something else. This vertex is either going to be... Let's talk about the axis first. Notice it doesn't have to be the y-axis. This axis splits that parabola in half. It's a line of symmetry. It could be any vertical line. It could be the line x equals 15. So when I say y equals some number, that's a horizontal line, right? Flat. When I say x equals some number, then that's a vertical line. Again, it's a line of symmetry, meaning if I have a point here, there's going to be a point the same height over here that's just as far away from that axis. That's going to help us when we're graphing these things. The vertex, since we're talking about a parabola, the vertex represents either the highest point, if it opens down, or the lowest point, if it opens up. And an important little fact, it lies on the axis. Here, just look at this. This is, like I said, it's the thing. If you understand what's in this box right here, everything in 3:1 opens up to you. Let's take a look at what it's saying. Don't write right now. Just let's go through it, and then I'll give you a minute if you want to write it down. It's in the book. First thing, we're starting off with the standard form of a quadratic. Ax squared plus bx plus c. That's the standard form. Remember, b and c could be 0, but a can't be 0 because it wouldn't be quadratic anymore. I want to change it to this form right here. Now, a couple of things. I'm not seeing, in the second form, I'm not seeing B and C in there any place. In the first form, I'm not seeing H and K. It turns out this second form, this one right here, can be pretty useful. It's called the vertex formula. Let's see how you get H. So we're looking at this right here. How do you get H? Well, you take the A and the B from your original form. You just make a fraction out of it, B over 2A, and stick a minus sign out in front. That's how you get H. And so let's say H came out to be 2, just for the sake of argument. When you do that, just turns out to be 2. How do you get K? Well, you take that 2 that you just got and plug it into your original formula. So you're evaluating that original formula at x equals 2. You're going to get a y value, that's K. And that's why it's saying right here, K is the y value when you plug H into the original equation, called the vertex formula. Here's the neat thing about it. The vertex is at this point right here, HK. So if you got 2 for H and you got -6 for K, the vertex is at 2, -6. Looking at that original thing, the ax squared plus bx plus c, whatever that is, you can't just look at that and tell where the vertex is. But if you change it to the vertex formula, now you can. And there's a bunch of homework problems that want you to do exactly that. All right, next thing. If a is bigger than 0, in other words, if a is positive, this parabola opens up, so both arms up. If a is negative, the parabola opens down. So if the parabola is opening up, we know the vertex is the low point. If it's opening down, we know the vertex is the high point. Now, if a is not 1, that graph is either being stretched or squished. That's what 3 is saying there. 4, interesting. How do you get the y-intercept? You just plug 0 in your original equation for the x's. So what happens? These first 2 terms drop out, and it's just c. That's why here it's saying x is 0, whatever, in the original equation, whatever c is. If it's -3, then your y-intercept is at 0, -3. Last thing down here at the bottom. Now I'll hush for a second and let you copy this down. This is talking about the discriminants. Remember what a discriminant is. It's the thing that's on the inside of the quadratic formula radical, right? That's the discriminant. If that discriminant is bigger than 0, if it's positive, then you're going to have 2 solutions. Meaning you're going to have 2 places that graph crosses the x-axis. If the discriminant equals 0, you're really going to have 1 solution. It's going to be a double one. So it'll touch the x-axis in one spot. So this first one would look like this. Maybe. The second one is going to touch. Go back up. What about the third one? No real solutions. So that third one, what would the graph look like? Something like that. The graph doesn't cross the x-axis anywhere. You have imaginary solutions, but no real solutions. Let's look at some examples about how to put this into practice. So I got f of x equals x plus 1 squared. Okay, what's a? Uh-huh. So now already I know something. This thing opens up. So it's going to be like that. What's h? Good, -1. Because if you go back to here, if you look at the vertex, if you look at the line says vertex formula, and then you look right above it, it's x minus h, right? So it's got to be -1 there. So now what do I know? I know that's my axis. That's my axis of symmetry. So that red line represents the axis of symmetry. I know the vertex is on that line someplace. What's K? Technically, this is plus 0, right? There's your K. All right, so now I just locked in where the vertex is. I know it's on that red line. It's at the point 1, 0. -1, 0, sorry. There's a vertex. I know it opens up, y'all, right? Because A is 1. How many places is this going to cross the x-axis? Right, just 1. So the vertex is the x-intercept here. Where's the y-intercept? Well, I'll go back up and I put a 0 in for my x's. So I've got 0 plus 1, which is 1 squared. That's 1. So it's there. So I know there's my y-intercept. I know I've got that red line axis of symmetry, so I know there's got to be a point over here just as high as the y-intercept. So now we need maybe a couple more points, and we've got 5 points, and we could sketch a graph off that. Notice I'm not using a table. I'm just getting the information from the equation, basically. So if I plugged a 1 into that, take away that 0, put a 1 in there. So I'd have 1 plus 1 squared. So that'd be 4. So there's my point 1,4. And I know that that's 2 to the right of the axis of symmetry, so I've got another one out here at, what, -3, 4. I could sketch that parabola now. We didn't need the x-intercepts because it's only got 1, and that's the vertex. Now, if I had a bigger piece of graph paper, I could find another point and make it prettier maybe, but that's the shape of that parabola. So we got x minus 5 squared minus 4. So this is in the vertex form, vertex formula form. That makes it a lot easier. So what's A? Once again, it's 1. What's h? 5. Thank you. That means the axis is x equals 5. Here's my axis. What's k? There it is. -4. So now I know my vertex is at the point 5, -4. Right there. Let's look at the y-intercept. If I put 0 in for my x, I've got 0 minus 5, so that's -5 squared. That's 25 minus 4, 21. So my y-intercept is going to be there. I can't graph it on this graph, but that's where it is. That's going to help you in some of the homework problems, by the way. Now the x-intercepts, what do I do? Well, let's go back to our original equation. I set this equal to 0. I've got a perfect squared there, x minus 5 times x minus 5. When I square that by foiling, I get x squared minus 10x plus 25 minus 4 equals 0. So if I just work that out, that's what I would have, which gives me x squared minus 10x plus 21 equals 0. Erase some of that out there. Okay. Now then, I can use the AC method. I'm going to factor it, or I could use the quadratic formula. This one's pretty easy to factor. If I do the AC method, I think it's going to come out to be x minus 7 times x minus 3 equals 0. So I set each of those to 0. Those are my two intercepts, x-intercepts. So at 3, 1, 2, 3, at 7, okay, so let's try plugging in a 2. Is that going to give me anything I can work with here? So if I plug a 2 into my original equation, 2 minus 5 is -3 squared, which is 9, minus 4, so it'd be 5. So at the point 2, 5, and I know over here, since that's an axis of symmetry, there's my other point. There's 5 points I could sketch a parabola. Now, the nice thing about these last two examples is they were in the vertex form, where I could find h and k pretty easy, just by looking, basically. Let's see what the next one holds for us. Unless somebody has a question. They're not always going to be in that form. This is in the form ax squared plus bx plus c. So, got a, b, c. There's technically a little 1 sitting out there. So what's a? Well, it's 1. tells me it's positive, it's going to open up. Now we got to find h. So I use that little formula. Minus b over 2a. Well, b here is 6. 2a is 2. So I'm getting minus 3. That's also my axis, so x equals minus 3. There's my axis of symmetry. How do you get k? Well, k, if you look back at that magic box I showed you, is going to be f of h, which means f of negative 3. So I plug a negative 3 in for my x's up there. So I've got negative 3 squared plus 6 times negative 3 plus 5. H is negative 3, so I'm just plugging it in. So I've got 9 minus 18 plus 5. So 9 and 5 is 14 minus 18, so negative 4. So my vertex is at negative 3, negative 4. Which is going to put it right there. I know it's going to open up. I know it's going to have 2 x-intercepts, so 2 solutions. What's the y-intercept here? I'll go back up to my original, and every place there's an x, I put a 0, so I got just 5, right? So I come over to the y-axis here and go 1, 2, 3, 4, 5. There's my y-intercept. But I know that axis of symmetry means that there's a corresponding point over here that I didn't have to figure out. So let's try and find one that's moving up pretty quick, it looks like. Let's try maybe negative 1. If I plug that into I'm just seeing in between the axis of symmetry and the y-axis. Now I could maybe factor that and everything, that's fine. Let's do that, because that'll happen a lot of times. So I've got x squared plus 6x plus 5. A couple of ways you could do it, equals 0. I'm going to factor it, and I think if you use the AC method, you'll get x plus 5, x minus 1, x plus 1. Now, I could use a quadratic formula. I should get the same answers. So I set my factors to 0. So I've got 2 more points. Here's where it's crossing the x-axis here. There's my x-intercept there, and at negative 5. We good? I could sketch that. Hello, let's look at this one. Dun, 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 dun. Let's start off with A. And I suggest you do this. I think the homework actually makes you do this to some extent. But even if it didn't, it's a smart way to figure these out. So what's A here? Negative 2. So I know this thing's going to open down. What's H? I'll use my little formula. minus b over 2a. Well, b here is negative 12. Keep all your signs straight. A is negative 2 times 2 is negative 4. So I've got these negatives cancel. So 12 over 4 is 3, so I've got negative 3 is h. That's also my axis. There it is. What's k? Well, I'll plug that negative 3 in up here. Remember, it's f of h. So negative 3 times negative 3 is 9, times negative 2 is negative 18. Negative 12 times negative 3 is positive 36. Negative 16. So I've got negative 34, positive 36. So 2. So my vertex is at the point negative 3, positive 2. So it's right there. Y-intercept, if I put zeros in for my x's, I'm just left with negative 16. I can't graph it, but here's where it would be. And now we need to find some points. So the first thing I would do, I could use a quadratic formula, but I'm looking at that, I'm seeing 2, 12, 16. If I divided everything set to 0. If I divided all 4 of those terms by negative 2, I would have x squared plus 6x plus 8. I can do that because I've got it set to 0. When I factor that, what am I going to get? X plus 2, x plus 4. If you don't see that, you could use the AC method. Okay, there's 2 more points. So my intercepts are at negative 2, negative 4. Let's try and get 2 more here. If I plugged in negative 1, what would I have? I could do it off this one right here, couldn't I? Or could I? Maybe not. So I'll plug in negative 1, so I'd have negative 2. Negative 1 squared minus 12 is negative 1 minus 16. So negative 1 times negative 1 is 1 times negative 2. So I've got minus 18 plus 12, so negative 6. So at this point, negative 1, negative 6, 1, 2, 3, 4, 5, 6. Because that's an axis of symmetry, I've got this one over here. So now I can sketch it. Not as bad as it looked. I do want to show you one last thing, because there's problems like this coming up. Okay, here they're talking about the discriminant. Just look at this with me. They're giving us 6 different situations. We've got 6 different graphs. Look at number 1. A is less than 0. What does that tell you? A is negative. It's going to open down. So that rules out A, B, and C. It's got to be one of the bottom 3. Now it's saying the discriminant equals 0. What does that tell you? One solution. It only touches the x-axis in one place. Well, that's got to be E, right? This thing opens down, touches in one place. Look at number 2. A is greater than 0. It opens up. The discriminant here is less than 0. What does that mean? No real solutions. Which one of the top 3 does not touch the x-axis? Well, A. Look at 3. A is less than 0. It's going to open down. The discriminant is less than 0. Doesn't touch the x-axis. It's got to be D. I know the bell's fixing to catch us. Look at 4. Less than 0, opens down. But the discriminant here is what? Positive. That means it crosses the x-axis 2 places. Got to be F. And so there's problems like this in the homework. They're going to have you drag and drop stuff to work them. But it's going to be very similar to this right here.